Hello, welcome to our lecture today. The lecture is about plant layout. In the previous lecture, we have explained the plant location and we mentioned that it is among the duties of an industrial engineer to select the best location for any facility. Now, it's also among his duties to determine the plant layout of the facility. So when I say plant layout, I mean by this, it is the designing of the arrangement of the physical things included in my facility. This means that I want to arrange machines found, people who are moving within the facility. So if I want to define plant layout, it is the technique of locating machines, processes, and services within the factory so that I can make sure that we have smooth transition of the products and people within this facility. Of course, I have to make sure that this arrangement must provide me the least possible cost of manufacturing. Now, sometimes you get to design the layout from scratch for new facilities, and sometimes you have an existing facility and you want to improve the layout to get the most efficient arrangement, which will give you the least manufacturing cost. We have three major types of layouts. We have the fixed position, product-oriented, and the process-oriented layout. Let's give a brief explanation about each one. With the fixed position, you are manufacturing a large thing, such as ships, airplanes, buildings. So here, the product that you are manufacturing, it is fixed. It doesn't change its position. You cannot move it or relocate it. With the product-oriented layout, the layout will follow the manufactured product. Let's say, for example, the product we are manufacturing is a car. So you will see that the layout will be formed in a certain sequence which allows me to manufacture these cars within the sequence it requires. Here I'm manufacturing high volume. I'm manufacturing large quantity of this same product. However, with the process-oriented layout, here the layout doesn't follow the manufacturing steps of a certain single product. No, it facilitates the manufacturing of several diverse products. We have high variety of products being manufactured in this type of layouts, but I have low volume. I'm not manufacturing huge quantities of the products. We have variety of products with low volume of manufacturing. So we refer to this type of layout as the job shop. Let's look here at the fixed position layout. As you can see here, the product that's being manufactured is stationary. Okay, it doesn't move. So that's why it's called fixed position layout, because all the equipment, all the workers, or the raw materials will come to it. So it doesn't move. Let's say, for example, if I'm building, if I'm having a construction project, okay? Here, this is the project site. Everything will come, the supplies, the raw material, the human resources. So we have some complicating factors such as the space. We have limited space because all the resources are coming to the site. So I have limited space and I have changing material needs. What do you mean by that? If it's the case of building construction, you notice that at the early stages of the construction, the material needed is basically the concrete and the steel. So these material will change as we go into later stages of the construction steps. For example, when we are at the finishing stages, we will require different materials. So we have changing materials, and we have the volume of the material needed is dynamic, so it's always changing. So I cannot set before the beginning of the project that this is the raw material required and it's stable throughout the stages. No, at each stage we have different types of materials and different volume. With respect to the product-oriented layout, the facility is organized around the product. We are manufacturing standardized products. Okay, you see, we have one type of product. It has almost the same features. Let's say I'm manufacturing some cars. Maybe only the thing that might change is the color, the final color of it. So basically it's a standardized product. Standardized because all the steps will be the same. I will go in the same sequence. I will get the same final output with slight differences between the products. And I will have high production volume. I'm manufacturing huge quantities of the same product all over again. So the layout follows the sequence that I request in order to get the final product. So that's why it's called product-oriented. Here the design minimizes line imbalance. What's meant by line imbalance? We need to balance the time needed at each station. Okay, and if I'm at the first step and I got the product out of this step and we need to go to the second step, I don't want to delay it between the workstation. I need to make the sequence of operation balance with respect to time. Almost each station takes the same amount of time spent so that I do not have any delays in the steps. We refer to the product-oriented layout as the fabrication line or assembly line. So with the line layout, all the machines and the equipment are arranged in a line depending upon the sequence of operation required for manufacturing the final product. So what happens? All the materials will move from workstation to another workstation without backtracking. Backtracking is going backward. So you need all the stations to go in a certain sequence. You cannot say that this product will go back into a step before. It has to be done, okay, without backtracking, without have to go back into another station. Everything has to keep moving on forward. So here the machines are grouped in one sequence, where the output of one machine becomes the input of the next. Let's look here at this example. Here, let's say the first product has to go to the lathe machine, then it has to be drilled, then it has to be grinded, then goes to the assembly, then for the painting. So this is the sequence, as if I'm moving in a line. All the workstations are arranged in a line, in one sequence. Product B maybe begins with the cutting, then the grinding, then milling, then goes to the lathe machine. At the end it's welded. So this is the line, production line related to product B. So we have to take into consideration the following and keep in mind these principles, that all the machines and the tools and the equipment must be placed at the point where I need it, in the sequence that I need it for, that so that the final product can be manufactured. There shouldn't be any points where we intersect, okay, or we have crossing between the lines. Even if I have the same operation being done in two production lines, and here with product A, I have grinding at the third step. With product B, I have grinding at the second step. These two lines cannot cross. I should have a workstation for grinding in the first production line for product A and a grinding station for product B. They have to be separate. This is an example of a line layout. You see how the product moves on a conveyor or on a belt from one workstation to another. Here it will begin with the first task. After this task is completed, the product will move on to the next workstation where the second task is performed. Then it will proceed to another workstation to perform the third task, and so on. It moves all the way on the conveyor until it is finally manufactured. The last type of layout is the process layout. In this type of layout, as we said, we do not follow the sequence of manufacturing a single product. However, we arrange the layout so that I can facilitate the manufacturing of several types of similar products. So we arrange machines that do the same operation in the same place. For example, machines that perform drilling operations are arranged in the drilling department. Machines performing casting will be grouped in the casting department. So as if I am having departments. This is an example of a shop floor where it follows the process layout. As you can see, this is the first department where I'm grouping all the saws. So this is the sewing department. Another department includes all the drilling machines. So this is the drilling department. So all the functions which are similar are grouped in one place. We have the offices, we have the tool rooms. Okay, so this is an example of a process layout. While I'm grouping the machines for the process layout, I have to keep in mind the following principles. First of all, the distance between the departments should be minimized as much as possible so that I can avoid long distances traveled. For example, when moving materials from floor to floor, this is a long distance to be crossed. So if I have long distances to be traveled when I'm moving from department to department, this is a waste of time, and ultimately it's a waste of money, because with this lost time I could have manufactured more parts of the final product. And I need to keep in mind that I should arrange the departments according to the sequence of operations. If I have some departments that are always in a sequence of each other, maybe it's better to keep those two departments next to each others to minimize the traveling distances. And I need to keep the arrangement as convenient as possible for inspection and supervision. Let's look at this example here, which is related to emergency room layout. As we agreed that the process layout, I'm not following the sequence for one single product, and the case applies also for services, okay, because each client that will come for service will not have the same order. So here in the hospital, each patient coming has a different case, has a different situation, so he will proceed to different departments. Let's look at patient A, for example, who came with a broken leg. First, he went to the department of triage room, where they do the first assessment, and then upon assessment they have decided that he needs to go to the radiology department, maybe to do some x-rays. Then out of there, after seeing the x-ray, they decided that he needs surgery, so he was moved to the department of surgery. Then after the surgery was performed, he was moved to his room. Then he proceeded from there to the pharmacy where he took some medicine, and then he was charged out. So you see this patient, he moved throughout the different departments, but in a different sequence. Not all of the patients will move in the same sequence. For example, patient B, who came with a heart attack, his case was critical, so they didn't pass through the triage room and spend time there. From the triage, on the spot, they have decided upon the first assessment that he should right away go to surgery. So he moved right away to the surgery, where after he finished the surgery, he was administered with some medicine, and then he entered his room, and then he took the medications and was charged out after he was feeling better. So you can see with this sequence, he didn't go to the Department of Radiology. So this is the difference between the product layout and the process layout. With the product layout, the product has to move in sequence in all of the departments. However, with the process layout, I have separate departments. I group the department with the functions that are done similarly. So we have a department for surgery, a department for x-ray. I have these departments. However, the product or the client shouldn't come in sequence with all these departments. According to the job needed to be done, he will go to the specific department. So the sequence is not always the same. Now, if I want to develop a process-oriented layout, because it includes different departments, and I need to go through these steps. First of all, we need to construct a from-to chart matrix, then determine the space requirements for each department needed, develop an initial schematic diagram, determine the cost of the layout, and then by trial and error, we have to try to improve the layout in order to get the least cost for this layout. This is what the from-to matrix or from-to chart looks like. You see here the numbers. This is number 1. So this is the first department, department 1, 2, 3, 4, 5, and 6. We draw it horizontally and vertically. You see here, 1 to 1, I have nothing moved from department 1 to 1 because it's the same department. However, if you look horizontally at number 1 and vertically at number 2, you will look and see that we have the number 50. What is this 50? This means that I'm moving each time from department 1 to department 2, I'm moving 50 units on average. And I'm moving from department 1, I'm still looking horizontally, okay, at department number 1, where it intersects department number 3 vertically with number 100. So this means that I'm moving 100 units on average from department 1 till department 3. From department 1 to department 4, I have 0 units being moved. And from department 1 to department 5, also I have 0 units being moved. From department 1 to 6, I have 20 units being moved, okay, on average per day. So you see, I'm as if I am presenting the load, okay, between departments, between the movement of units from department to a department. You see at the second row, row number 2, this is department number 2, we have nothing between 2 and 1. Why? Because we agreed that there is no backtracking, we do not go backward. So from department 2 to department 1, we have nothing. From department 2 to department 2, we are not moving anything because it's the same department. The first number will appear is the intersection between department 2, okay, and department 3 with 30 units, okay, because we are agreeing that we have to move forward. And from department 2 to department 4, we have 50 units. From 2 to 5, 10 units. From 2 to 6, 0 units. It's the same case here when I look horizontally at row number 3, which is related to department 3. I have no movement from department 3 to department 1, 2, or 3. The first number will begin from moving things from department 3 to 4 with 20 units, and from 3 to 4 with 0 units, from department 3 to department 6 with 100 units. This is the layout. It's called from to matrix or from to charts, where I see the flow of parts from department to department. Now, if I give a try and allocate the departments in this manner. So this is the first possible layout. I said that I will arrange the first department, okay, which is the assembly department, next to the second department related to painting, and next to it I will have the machine shop department. Then I will have the receiving department close to department A and department 5. Shipping is between the receiving and testing. So this is a proposed layout. Okay, you have to take care into consideration the dimensions of the department, the dimension of the whole floor, shop floor that you have, and we will test. What if I arrange the departments in this way? Would this provide me with the best layout, the best efficient, and the one that has the least cost? Let's see. This diagram shows the flow between departments. It states the load as well. So you can see here from department 1 to department 3 we have 100. So this is the weekly load between department 1 and department 3. As you can see also we have the flow between department 1 and 2. It is 50. From 2 to 3 it is 30. So we can see that the maximum load is between department 1 and department 3. So why don't we try to switch between departments so that we can make department 1 closer to department 3, so as to minimize the distance traveled between these two departments. You also see that we have some interesting intersecting lines. We have crossing between the lines. This is a possible layout. What if I enhance it? Let's see if I propose another possible layout, how will the flow graph becomes. Here I decided that I'm gonna switch department 1 and 2. You can see that department 1 becomes in between department 2 and 3, so it's more close. It's next to department 3, so that we can minimize the traveling distance between department 1 and 3. See now that we have a smoother flow between the departments. We have less intersecting lines as well. So this is a better proposed layout. Now, if you want to make sure that this is really the best layout, we have to take into consideration the cost as well. But this will be elaborated more when you take the course of facility layout in third year. It's a whole course that will help you know which layout is the best. You have to do some calculations. You might use some software packages or add-ins in Excel to help you decide whether this is the best layout. Does it have the least manufacturing cost, the least travel distance between departments, or not? You have to keep in mind the following factors: the nature of the building that you're designing the layout for, its size, the nature of the product. As we mentioned, if it's a uniform product, then the best layout would be a product layout. But if you are dealing with more custom-made products, then the best layout is the process layout. Moreover, you need to take into consideration the type of machinery. Is it general purpose machine? So the best layout is a process layout. Or is it more special purpose machines? So it's better to keep it as a product layout. Also, you need to take into consideration repairs and maintenance. So the machines has to be arranged in a way that we have space for the technician to come and check the machines and do the repairs easily. Don't forget the human needs as well. You have to provide comfortable zones for the employees and workers to move and do their works with convenience. You have to provide washrooms, toilets, and some space to put their things, lockers. You have to make sure also that the plant environment overall is well prepared. You have to make sure that we have proper lighting, ventilation. If you have some departments related to painting, you have to locate it in faraway holes so that no one smells the dangerous fumes. So all these things must be considered when you are proposing or designing the layout of any facility.